In this video, you'll learn how a single landslide triggered the tallest tsunami ever recorded, and what that means for tsunami risks today. Back in 1958, in a remote part of Alaska, nature showed its power in a way few people had ever seen. Imagine calm waters inside a narrow fjord, then an enormous wall of water crashing down like nothing on Earth. By the end, we'll also ask, could something like this happen again, and how are scientists watching for it? The story begins on the night of the 9th of July, 1958, Lituya Bay, Alaska. A strong earthquake struck. This shook loose a huge chunk of mountainside near the head of the bay. In just seconds, about 30 million cubic meters of rock, roughly equivalent to a small mountain, thundered into the narrow inlet. Fishermen anchored in the bay saw what happened. First, they heard a great roar and saw avalanches from the mountain. Then came an explosion of water in Gilbert Inlet. The fishermen described the wall of water as at least 100 feet high by the time it passed their boats. In fact, one survivor, Howard Ulrich, steered his boat up the face of the wave, snapping his anchor chain, and somehow kept the motor running all the way. Another boat, the Badger, was picked up near the bay's entrance. Bill Swanson saw his boat riding atop the wave, 125 feet above the normal shoreline, before crashing down. He and his wife escaped to safety in a small skiff. A third boat, the Sunmore, was lost, and its two occupants were never found. By the next day, aerial surveys and field studies revealed the full scale of the disaster. Everywhere around the bay, forests were stripped bare. The highest trim line, where trees had been knocked off the slopes, was measured at about 1,720 feet above the water. In other words, the wave washed trees away up to 524 meters high, taller than any human-built structure. Scientists found driftwood, logs, even rocks scattered at those heights. It was the largest tsunami wave ever measured in modern times. How could a landslide make a wave that tall? After the event, researchers investigated carefully. Geologist Don Miller flew in and spotted a huge landslide scar high above Gilbert Inlet, where the rock had dumped almost instantaneously into the water. It turns out the speed and weight of that falling rock did something special. Experiments and models show that when a massive slide hits the water very quickly, it can trap a big bubble of air and push far more water than you'd expect from the rock's volume alone. In one scaled-down lab test, scientists blasted simulated rocks into a model bay and recreated Lituya's run-up. They found the rapid impact created an air cavity in front of the slide, propelling the water skyward. In simple terms, the landslide acted like a giant plunger. The enormous chunk of rock threw water up the bay walls. The result was a wave that crested at the bay's outlet and then raced outward. Don Miller noted that part of the wave even jumped over the ridge opposite the slide and hit a second shoreline in the bay, explaining multiple trim lines. When the wave finally reached the fishermen's boats near the mouth, only minutes had passed since the earthquake. It was too late to escape further. The boats were carried through the narrow opening within 5 minutes of the quake. In the years after Lituya Bay, scientists realized this was not just a one-off curiosity. The event forced a rethink of tsunami hazards, showing that landslides and rockfalls can create megatsunamis as dangerous as those from earthquakes. And in fact, Lituya Bay had seen other big waves before. Historical records show tsunamis of hundreds of feet in 1854, 1899, and 1936. Today, we ask, are there other places on Earth where a similar disaster could happen? The answer is yes. Any steep, narrow fjord or bay with loose slopes can be at risk. For example, in 2015, another Alaskan fjord saw 180 million tons of rock crash into the water. That was even larger than Lituya, and it generated a wave with about a 600-foot run-up. Elsewhere in Alaska, scientists keep an eye on spots like Berry Arm, where satellite radar and airborne sensors watch for any slope creep that might threaten to fall into the sea. They are even planning to install tide gauges there, so if a slide happens, any tsunami could be detected immediately. The danger is global. In Greenland, for instance, a landslide in 2023 sent a wall of water up to 110 meters high through a fjord. That event sloshed water back and forth for days and even created seismic waves felt around the world. In Norway, engineers worry about similar risks. One famous cliff near the village of Åkernes has been splitting. Models suggest if it collapses, it could send a 300-foot wave down Geiranger Fjord. Local authorities there have installed laser radar monitors on the crack, scanning it constantly. If the rock starts to move noticeably, alarms will sound and residents would be evacuated from the fjord in time. What's causing these slopes to fail more often? Part of the story is climate change. When glaciers and permafrost melt, they remove support at the base of mountain slopes. Added rainwater can also seep into cracks, making rockfalls more likely. In Greenland's recent case, scientists traced the slide to a glacier thinning. The ice was holding up the peak, and when it thinned, the mountain let go. In Norway, heavier rain in winter may speed up cracks in the rocks. In short, places with steep walls rising directly out of deep water, fjords, are natural trap zones for this hazard, and a warming planet can make them less stable. So, could it happen again near you? If you live by the ocean or a steep bay, it's wise to know the risks. Many countries now map potential tsunami paths and put warning systems in place. In Alaska, for instance, the Lituya Bay event is so famous that even now, residents and boaters are cautioned about sudden slides. Studies often advise, if you feel strong shaking near the coast, head uphill immediately, even before any tsunami warning comes. Fortunately, monitoring and education help. Geologists use satellites, drones, and ground sensors to watch known unstable slopes. Ocean buoys and tide gauges can give a few extra minutes of warning if a tsunami is generated. Villagers in Norway practice evacuation drills based on laser alarms on that Åkernes crack. And scientists worldwide are identifying the most dangerous cliffs so people can be prepared. In the end, the story of Lituya Bay is a dramatic reminder of nature's power, but also of human curiosity and caution. Researchers used that 1958 event to learn how landslide tsunamis work, and now pass that knowledge forward to keep communities safe. As one expert put it, even in beautiful places, we must remember to live wisely with the risk. The next time you look at a calm bay or fjord, you might ask, what hidden forces lie beneath? Thanks to science, we have better answers than ever, and better ways to stay out of harm's way.